Write the equation in standard form for a circle with center -3, 5, and tangent to the x-axis. So we're trying to write the equation of a circle. So let me write down what the standard form of a circle is first. The standard form of a circle is x minus h squared plus y minus k squared equals r squared. And that's where HK is the center of the circle and R is the radius. Now we are given the center of the circle to be -3, 5, so that means we know the values of H and K. So the only other value we need to know to find the standard form of a circle is the radius. And hopefully this other information about being tangent to the x-axis will be able to tell us what that radius is. So let's have an understanding of what it means for a circle to be tangent to the x-axis. And we'll do that with a picture. So here is the coordinate plane, and the horizontal line is the x-axis. If I were to draw a circle that is tangent to the x-axis, what that means is that the circle will touch the x-axis in a single point, rather than the circle crossing the x-axis or totally missing the x-axis. So this example here, let me change the color of it. This example here is a circle that is tangent to the x-axis. So what that does for us is it allows us to determine the value of the radius. If I start to draw this picture, I think it'll become more apparent to you. So for the example that we're working with, we have a center of -3, 5, and I know that the circle I want to draw is going to be tangent to the x-axis. And so that must mean that if I go down to the x-axis, this is the point that the circle is touching the axis at. And because of that, it's really easy to count how much we are, count the distance from the center to that point on the x-axis. So this ordered pair for the center is -3, 5, so that must mean that our radius is 5 for this particular circle. So we now know the radius of the circle is 5, and we can fill in H, K, and R into the standard form of the circle. So we have x minus -3 squared plus y minus 5 squared equals 5 squared. I'll simplify this double negative and simplify the squared, and that gives x plus 3 squared plus y minus 5 squared equals 25. So we have the standard form of a circle that has a center of -3, 5 and is tangent to the x-axis. On this question, we want to find the center, the radius, and the intercepts of the circle given below, and then sketch the graph of the circle. So the equation that we're given is x minus 1 squared plus y plus 5 squared equals 4. And luckily this equation is written in standard form, which allows us to find the center and the radius without any calculation. So the standard form is x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. So we're going to be able to recognize the center as being 1, -5. So let's talk about why it's -5. There is a minus in my formula and there's a plus here. So I need to fix that. So I could write this as y minus -5 squared. And now my equation matches the formula. So the number after the minus is -5, and that's our k. So we have a center of 1, -5. And we could also do that with just a shortcut. When you're looking at this, you could just choose the opposite of what you see. So because there's a minus here, you can do the opposite of what you see. That's a -1, so we're going to use a +1 in our center. This is a +5, so we're going to use a -5 in our center. And then over here, the radius squared is 4. I know that 2 squared is 4, so that means my radius is equal to 2. So finding the center and the radius, we really could just recognize it from the equation. To find the intercepts, we're going to have to do some calculation. So to find an x-intercept, we're going to let y equal 0 in our equation right here. So let's take this equation. X minus 1 squared plus y plus 5 squared equals 4, and we'll substitute a 0 in for y. That's x minus 1 squared plus 0 plus 5 squared equals 4. And we'll simplify. That's x minus 1 squared plus, following order of operations to simplify this, 0 plus 5 is 5, and 5 squared is 25. So I have x minus 1 squared plus 25 equals 4. And I would subtract 25 on both sides. And that gives x minus 1 squared equals -21. And then I'll square root both sides to get rid of that square. And the square root and the square cancel each other out, and I've got x minus 1 equals the square root of -21. Now that's going to simplify to I square root of 21. I'm going to add 1. That gives x equals 1 plus or minus I square root of 21. I left off this plus or minus up here. We get that whenever we square root a square. So you might think that I have just found the y-intercept, the x-intercept. However, because we got an imaginary number within our answer, we're not going to be able to graph that on our typical coordinate plane. So because we got an I, we're going to say that there is no x-intercepts. So then let's find our y-intercept. We're going to find our y-intercept by letting x equal 0. So we've got our equation, x minus 1 squared plus y plus 5 squared equals 4. And I'm going to replace that x with the 0. 0 minus 1 squared plus y plus 5 squared equals 4. Following order of operations, 0 minus 1 is -1. The rest I'm copying down. -1 squared is 1, and the rest I'll copy down. And I'm going to solve this by isolating the square and everything it's attached to. This is called the square root method. I subtract 1, and we get y plus 5 squared equals 3. I'm going to get rid of that square by square rooting both sides. The square root and the square cancel each other out, leaving you with y plus 5. I get that plus or minus symbol on the other side, and I can get y by itself by subtracting 5. So I've got my y-intercepts being negative 5 plus and minus square root of 3. So I've got no x-intercepts and y-intercept of negative 5 plus and minus square root of 3. So the last thing in the directions asks me to sketch a graph. So I've got a grid here. In order to sketch it, I need the center and the radius. Let me make this a little bit smaller. So we have a center of 1, negative 5. 1, negative 5 would be right here. We have a radius of 2. I'm going to go up 2, to the right 2, down 2, and left 2. And I'm going to sketch the circle from there. So this is just a sketch. And hopefully this lines up with what you found in the intercepts. So notice that here's my x-axis, and the circle doesn't reach the x-axis, so we have no x-intercept. And for our y-intercept, we do have 2 places where it crosses, and this plus and minus indicates those 2 places. Find the center, radius, and intercepts of the circle with the given equation and then sketch the graph. Our equation is x squared plus y squared plus 2x minus 10y plus 1 equals 0. So this is the equation of a circle, and this equation is written in the general form. We've got the general form of a circle. And in order for us to find the center and the radius, we need to convert this general form into standard form. And standard form is when you have x minus h squared plus y minus k squared equals r squared. And what we're going to do is we're going to use completing the square in order to do that conversion from general form to standard form. So with completing the square, you want to group your x terms together and group your y terms together. So that would give us x squared plus 2x grouped together. And we'll group the y squared minus 10y together. And this this plus 1, we're going to subtract 1 on both sides to move that constant to the other side. So we've done the grouping, and now we'll use the completing the square process. And with the completing the square process, you take the coefficient on your x term, so I'm going to take 2. You divide that by 2 and square it. 2 divided by 2 is 1, 1 squared is 1, and we consider 1 to be sort of like our magic number. And what it's going to do is it will, if we add it to our x group, it will make that x group factor into a perfect square. So we're going to add that 1 to the x group. But we have to balance the equation. So whatever we do to one side of the equation, we have to do the same thing to the other side. So we're also going to add 1 to the other side. Now we're going to do this again with the y group. So we start with the coefficient on the y term, negative 10. We're going to divide that by 2 and square it. Negative 2 over 2 is negative 5, and negative 5 squared is 25. So that gives us our magic number for the y group, and that's going to cause the y group to factor into a perfect square. So in the y group, we're going to add 25. To balance the equation, we'll also add 25 to the right-hand side of the equation. So now when we look at the x group, we're going to try to factor it. And we factor it, we get x and x, 1 and 1, with both pluses. And you can see that we have x plus 1 times x plus 1, which is the same thing as x plus 1 squared. That's our perfect square. The same thing will happen to the y group. When we factor the y group, y squared minus 10y plus 25, we're going to get y times y is y squared. 5 times 5 is 25, and we need minuses there. And we have y minus 5 times y minus 5, which is y minus 5 squared. So that y group factored to a perfect square. And then with our constants, negative 1 plus 25 is 25. So we were able to start with the general form, and using completing the square, we've now turned this into the standard form. And now that it's in the standard form, we can recognize the center and the radius. The center is the ordered pair HK, and we have on the right-hand side the radius squared, so we can identify the radius. So the center of this circle is negative 1, 5, with a radius of 5. We have a little bit more to do. We want to find the intercepts of the circle and also sketch a graph of the circle. So we'll find the intercepts, and I'll use the standard form to find the intercepts because it's a little bit easier. So to find an x-intercept, I'll let y equal 0. So using my standard form, x plus 1 squared plus y minus 5 squared equals 25, I'll substitute a 0 in for that y. And that gives x plus 1 squared plus 0 minus 5 squared equals 20. Excuse me, I copied that wrong. That should be 25, not 20. And if we continue, we'll have x plus 1 squared. 0 minus 5 is negative 5. Negative 5 squared is 25. I want to isolate this square term, and I do that by subtracting 25 on both sides. And that gives x squared plus 1, that's x plus 1 squared. X plus 1 squared equals 0. Let's get rid of the square by square rooting both sides. That's x plus 1 equals 0, and I subtract 1, and x equals negative 1. So we do have an x-intercept. And that x-intercept is negative 1, 0. Now I'll find the y-intercept. I'll find the y-intercept by letting x equal 0. So substituting a 0 in for this x position would give 0 plus 1 squared plus y minus 5 squared equals 25. 0 plus 1 is 1. And 1 squared is 1. And once again, I want to isolate this square term. I'll do that by subtracting 1 on both sides, leaving me with y minus 5 squared equals 24. I'm going to get rid of that square by square rooting both sides. And that leaves me with y minus 5 equals plus and minus square root of 24. And I'll try to simplify that radical. We can write 24 as 4 times 6. And the square root of 4 is 2. We'll leave the 6 inside. And I'll isolate y by adding 5 to both sides. So we have y equals 5 plus or minus 2 square root of 6. And that gives us our two y-intercepts. The y-intercepts will be 5 plus 2 square root of 6 and 5 minus 2 square root of 6. So we have one final thing to do, which is to sketch a graph of the circle. And to sketch a graph of the circle, we only need the center and the radius. So the center is negative 1, 5 with a radius of 5. Our center is negative 1, 5 with a radius of 5. Negative 1, 5 would be here. That's our center. From the center, we're going to use the definition of the radius. So the radius is the distance from the center to the points on the circle. So if we go a distance of 5 units up, we get here. That point will be on the circle. A distance of 5 units right, that point will be on the circle. A distance of 5 units down, this point will be on the circle. And a distance 5 units left, this point will be on the circle. So now these 4 points are on the circle, and we can sketch the rest of the circle from there. So we have that sketch of the graph of a circle. This question says, find the slope of the line containing the pair of points, negative 7, 5, and 3, 3. So we have a formula for slope, and the formula for slope involves having 2 points on the line, and the formula is y2 minus y1 over x2 minus x1. And that's when your ordered pairs or points on the line are x1, y1, and x2, y2. So we'll label these points that we're given as x1, y1, and x2, y2, and use the formula to calculate the slope. So for our slope, we have y2 being 3, minus y1 being 5, over x2, which is 3, minus x1, which is negative 7. So that would give me a negative 2 in the numerator, and in the denominator I have minus a negative, which is plus. 3 plus 7 is 10, and I'll reduce that fraction to be negative 1/5. So the slope of the line containing the points negative 7, 5, and 3, 3 is negative 1/5. This question says to graph the line that contains the point negative 3, 3 and has a slope of 2, 3. So to graph the line, I'm going to plot that point negative 3, 3 right here. And then I need to find a second point on the line using that slope. So we have to remember what slope stands for. Slope is rise over run, or the change in y over the change in x. So I can start from that point that I plotted, negative 3, 3, and rise to, so I'll go up 2, I'll change y by 2, and then I'll change x by 3, so I'm going to run 3. And that's going to lead me to a second point on that line. And with that second point, you only need 2 points to graph a line. I'll be able to draw that line that connects those 2 points. So there we've drawn the line that contains the point negative 3, 3 and has a slope of 2/3. Thank you for checking out my videos. Have a great day.